Right, today in geometry, we're going to look at the last section of chapter 8, 8.6, identifying special quadrilaterals. So here I start out with just our family tree. So we start out with quadrilateral. That just means any four-sided polygon. Then we have parallelograms. Underneath parallelograms, we have rectangle and rhombus. Underneath rectangle and rhombus, we have squares. Then underneath quadrilaterals, we have trapezoids and isosceles trapezoids, and then we have kites, all out there by themselves. So we're going to start out. It says quadrilateral ABCD is at least one pair of opposite angles congruent. What types of quadrilaterals will meet this condition? So at least one pair of opposite angles congruent. Well, I know that's a parallelogram, so here we're going to list everything that meets this. So underneath the parallelogram, we know that we have a rectangle that will have one pair of opposite angles congruent. We will have a rhombus that meets that, and a square. But then remember that we also have the kite that has one pair of opposite angles congruent. So parallelogram, rectangle, rhombus, square, and kite all have at least one pair of opposite angles congruent. So next we're going to look at pictures. What is the most specific name for the quadrilateral? So in this very first one, what do we know? We know that the diagonals have bisected each other. That's all that I know. I don't know anything about the sides being congruent. I don't know anything about any of those angles. So all I can say about this one is that it is a parallelogram. The second picture, what do I have? I have that my diagonals are congruent. Well, what do I know has diagonals congruent? The very first one I know that my diagonals are congruent is a rectangle. The next one, what do I know? I have one pair of parallel sides. And then I have base angles congruent. Therefore, I know that this is an isosceles trapezoid. So identifying from the picture the most specific name that we can give something. And next, we're going to tell whether enough information is given to classify the quadrilateral by the indicated name and explain why or why not. So number one, it says it's a parallelogram. So what do I know? I have marked opposite sides are congruent. So yes, that's enough to say that it's a parallelogram because one of its properties is that both pairs of opposite sides are congruent. The second one, it has all four sides marked congruent, and it says it's a square. Is that enough to tell me it's a square? No. How do I know it's a square and not a rhombus? So no, there's not enough information. In order to call it a square, I need four right angles. Number three, they said, okay, this is a trapezoid. I have two angles that are congruent down there. But remember that a trapezoid has to have one pair of parallel sides. So no, I do not have enough information to say that this is a trapezoid because there are no parallel sides. Great, so let's flip it over. Which pairs of segments or angles must be congruent so that you can prove that ABCD is the indicated quadrilateral? And explain. And then I said there may be more than one right answer. So a rectangle, okay? If I was going to prove that this was a rectangle, what would I need? I would need to know that AB is congruent to CD. I would need to know that AC is congruent to BD. I would need to know that my diagonals are congruent. So I would need to know AD congruent to BC. So I would either need both pairs of opposite sides congruent or those diagonals congruent. Either one of those would be enough to explain that that is a rectangle. Number 2, a parallelogram. I have that AB is congruent to CD, okay? So I would need to then know that AC was congruent to BD. So that would give me opposite sides congruent, or I would need to know that my opposite angles are congruent. So, or I would need angle A congruent to angle D and angle B congruent to angle C. So either of those would give me enough information to say it's a parallelogram. Okay, number 3, isosceles trapezoid. Let's see, I've got one pair of parallel sides, so I could get base angles congruent. So I could get angle A congruent to angle B, or angle C congruent to angle D, so that would get me base angles. Or I could get that my legs were congruent. So, or I could have AC congruent to BD. So that's what I would need in order to say that that is an isosceles trapezoid. All right, so now give the most specific name for quadrilateral PQRS and justify your answer. Here, they don't give me a picture, they just give me points. So we need to plot the points and draw the picture. So over -2 up 4, that is point P. 3, 5, that is Q. 4, 2, that is R. -1, 1, S. So if I'm going to be able to identify this, I need to know the lengths of these sides, and I need to know, are they parallel? So I'm going to go ahead and just do the slope first. So I want to do the slope of segment PS. I could use my slope formula, or I could make a right triangle, right? I have 1, 2, 3, 1. So the slope from P to S is down 1, 2, 3 over 1, -3 over 1. The slope of QR, again, 1, 2, 3, 1 up there. So down 3 over 1. So I see that I can say that PS is parallel to QR. So now I want to find out what is the slope of PQ and SR. So the slope of PQ. So how far up and over? So up 1 over 1, 2, 3, 4, 5. So 5 over 1. The slope of SR. Up 1 over 1, 2, 3, 4, 5. 5 over 1 again. So I see that PQ is parallel to SR. So I have 2 pairs of parallel sides. So I've got opposite sides parallel. Now I want to find out what is the length of these. Okay? I can do the distance formula or Pythagorean theorem. I'm going to go ahead and do Pythagorean theorem since I've drawn my right triangles. So I'm going to find out what is the length of PS. Okay, so PS, I'm looking right there, that X. So PS, I can say X squared equals 3 squared plus 1 squared. So 3 squared is 9, 1 squared is 1. So 9 plus 1 is 10. Take the square root of that. So PS is equal to the square root of 10. Now I'm going to do QR. Again, I have the same right triangle, 1 and 3, so I should end up with the same thing. X squared equals 3 squared plus 1 squared is 9 plus 1, square root of 10. So I see that QR is also the square root of 10. So I can now say that PS is congruent to QR. So now I'm going to find the length of PQ. Okay. And again, I can do a right triangle. This was 1, this was 5. So now I'm going to do PQ. So X squared equals 1 squared plus 5 squared. So 1 plus 25 is 26. Take the square root of that. So PQ is the square root of 26. And now I'm going to do this right triangle here. Again, 1 and 5. So SR Get the same thing, 1 squared plus 5 squared. So again, I'm going to get 1 plus 25, 26, take the square root. So SR is the square root of 26. So now I see that PQ is congruent to SR as well. So I have opposite sides congruent. Up here I meant to say that opposite sides were parallel for my blue ones. So opposite sides parallel, opposite sides congruent. I can check to see, are PQ and QR, are they perpendicular? If so, then they would have a right angle. Okay, so PQ, my slope was 5. QR, my slope was -3. Those are not perpendicular slopes. So therefore, all I can say about this is that it's a parallelogram. So my specific name is a parallelogram, because I have opposite sides parallel, opposite sides congruent, but no right angles. Okay. So number 2, we're going to do the same thing. So plot the points. So -1, 2. There's P. 4, 4. There's Q. 2, -1 is R. -1, -1 is S. Okay. So there's our picture. Again, I'm going to find the slopes of them first. So from the slope of PS, so let's see, I have to, from P to S, I don't go over any, I just have a vertical line. So remember that the slope of a vertical line is undefined. So my slope of PS is undefined. I see that I don't have any horizontal lines, so I know I don't have any right angles in there. I can tell that PQ and QR are not parallel, so I have no perpendicular or parallel lines. Okay. So that takes out all of my parallelograms. Okay. So now I want to find the lengths of these. So SR, that's going to be an easy one because it is horizontal line here. So S to R, 1, 2, 3 is 3 units. P to S, sorry, I do have PS and SR are perpendicular. I have one perpendicular line. I don't have no parallel lines, but I do have, this is perpendicular, so I know I've got a right angle right there. PS, again, is a vertical line, so I can just count those spaces, 3. So now I want to find P to Q. I'm going to do my right triangle. So up 2 over 1, 2, 3, 4, 5. Let's see, make sure I counted that right. 1, 2, 3, 4, 5. So PQ, so I would have x squared equals 2 squared plus 5 squared. So p squared is 4, 5 squared is 25. So 29, so the square root of 29. So PQ is equal to the square root of 29. Now I want RQ, so down and over 2, 1, 2, 3, 4, 5. So I'm going to get the exact same thing there. On RQ is also going to be the square root of 29. So what I have 2 pairs of consecutive sides congruent. And therefore, my only option is a kite. Okay? So that's our last section, being able to identify the special quadrilaterals that we have. Our homework will be worksheet 8.6 along with the test review. Tomorrow in class, we will go over the test review together and then take our Chapter 8 test and Chapter 8 vocabulary test on the next day.